Okay, this lesson is on solving rational equations. It's the last lesson of the semester, and it's probably one of the easier ones within this unit. Solving rational equations, you've solved basic rational equations before in Algebra 1, but there really are two different types of rational equations to solve. The first one can be used or can be done using cross multiplication. As you can see here, you have one fraction equaling another fraction. And when you have one fraction equaling another fraction, you simply just do cross multiplication to solve. So this times this and this times this. You do have to be careful though. When you do the 2 times the 2x minus 7, it does need to be multiplied to both of them. So it'd be 2 times 2x, which is 4x, 2 times negative 7, which is negative 14, equals going the other direction. But just like the other direction, you do need to multiply both of them. So x times 5 is 5x, and 8 times 5 is 40. Then you just simply solve. Okay, this is a linear equation. I don't have any squareds or x squareds or quadratics, so I'm just going to solve for x. It's just as simple as that. So I'm going to subtract the 4x over here, which gives me negative 14 equals 1x, or just x plus 40. And then I'll subtract the 40 over, and I'll get, move that down, x equals negative 54. So some of them can be just as simple as that. Other times you'll get a little bit more complicated equations. So when we look at, let's look at number 2. So I'm going to cross multiply here. So x times x is x squared equals x times negative 4 is negative 4x, and 1 times negative 4 is negative 4. So, unlike linear equations like the previous problem, in the previous problem you could just solve for x, but in this problem we have a quadratic. This x squared tells us that we have a quadratic, and in quadratics, if you remember from a couple units ago, you have to have everything on the same side of the equal sign. So I do have to move this over, I do have to move this over. So what I have is x squared plus 4x plus 4 equals 0. Now, just like with anything in terms of math, there are multiple ways to solve quadratic equations. You could put that into quadratic formula and get your two answers, or you could realize that this is factorable. What multiplies to be 4 and adds to be 4? Well, it's 2 and 2. So since they're both the same, my answer is just x equals negative 2. Because if you set it equal to 0, subtract the 2 over, you get x equals negative 2. And that's your answer. So if we were relating this to difficulty, number 1 would be an easy one. Number 2 would sort of be medium because you get a quadratic. 3 would be a little bit more challenging just because of the amount of work that's required. You're still going to get a quadratic in this case, but you'll see that it's not any more difficult. What makes this a little bit more difficult is I have to do all of these multiplying. So when I multiply this times this, I have to multiply both terms by both terms. So I have to do sort of like a FOIL here. So x times x is x squared. 1 times x is x. And then I have to do the others. X times negative 6 is negative 6x, and 1 times negative 6 is negative 6. And that's just one side. So when I combine this, I get x squared minus 5x minus 6 equals, now, get that out of the way and make it less confusing here. Now I'm going to go the other direction. x times x is x squared. X times 2 is 2x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. So now that I'm done multiplying everything, I can start combining like terms. So one of the things I'm going to do is move everything to the same side. So you'll notice that when I bring the x squared over in this case, when I subtract the x squared and subtract the x squared, what happens? Well, they cancel. So what I'm left with is negative 5x minus 6 equals, now I'm going to combine these two. 2x and negative 3x is negative 1x minus 6. And I'm going to solve. Let's see, I'll add the 5x over. So I get negative 6 equals 4x minus 6. Add the 6 over. You'll see that those also cancel, leaving me with 0 equals 4x. So if I divide by 4, x equals 0. And so you can see that that problem's a little bit more work to it because of the sort of all the multiplying that you have to do. So the first one would be like an easy one, the second one would be like a medium one, and 3 would be sort of a little bit harder than that. And 4 is the same thing. You can do 4 if you want for practice and check your answers with me. Or move on. That's cross multiplication. So that's what happens when you have a fraction equaling a fraction and you have to use cross multiplication. The other type is where you combine addition and subtraction in an equation. Now you might think that this might be more difficult, but you'll see it's actually easier than adding and subtracting. Remember that when you added or subtracted, you needed to find a common denominator. Or if you like my child analogy or toddler analogy where they always want what the other one has, it makes this real easy. So first off, I have to find a common denominator. So this, you have a denominator here of this and a denominator here of this. So the fraction on the left here has a 7, but he sees over here, it's like, hey, wait a minute, that one's got an x. I want an x. So this one gets an x multiplied to it. The one over here is like, hey, wait a minute, that guy's got a 7. I want a 7. So you multiply this one by 7. And that's really all there is. Now the final one, 6, is 6 over 1, doesn't have either of them. The one over here is like, hey, that kid's got a 7 and that kid's got an x. I want a 7 and an x. So you have to multiply by both of them. Now, in this process, I'm not going to go into detail of why this happens, but by multiplying everything by a common denominator, your denominators actually are going to cancel out. So you just do the simple multiplication and solve. X times 4 is 4x minus 1 times 7 is 7 equals 6 times 7x, which is 42x. Now, I just solve. Subtract the 4x over. That's going to get a funny fraction here, but I get negative 7 equals 38x. Divide by 38. And I get x equals negative 7 over 38, which I know is a weird number, but that's what it is. So they can be that simple. So let's look at 6. Remember, each fraction wants what the other one has. So this fraction over here, the denominator is like, hey, wait a minute, this guy's got an x plus 2. I want an x plus 2. So you multiply this side by x plus 2. And then this one's like over here going like, hey, wait a minute, that guy's got an x plus 1. I want an x plus 1. So you multiply this by x plus 1. The answer, the last term over here is like, hey, that one's got an x plus 1. I want an x plus 1. So you multiply by x plus 1. Essentially, you're just multiplying by whatever denominator is missing. You have x plus 1s and x plus 2s. So whatever one that the denominator doesn't have, that's what you multiply by. Now again, I'm not going to go into this unless you want to know. You can come ask me. But why this happens? But when you multiply everything by a common denominator, your denominators will cancel out. So all you do is all the multiplication. So 3 times x is 3x. 3 times 2 is 6. Plus 4 times x is 4x. 4 times 1 is 4. Equals 15 times x is 15x. And 15 times 1 is 15. And you just solve. 3x and 4x make 7x, 6 and 4 make 10. Subtract the 7x. I'm going to move the 7x over here by subtracting it. And I get 8x. I'm going to move the 15 over here by subtracting it. That's negative 5. Divide by 8. Divide by 8, and you get x equals negative 5/8. So that's solving. We'll do one more type of problem. Okay. What about a problem like this? So here's where I'm going to need, remember, whenever possible, you should always try to factor if you can. So whether that's GCF or ABC or whatever, if you look at this term here on the end, I can take out an x here. I can factor it using GCF. So if I take out an x, I get an x plus 4. So now it's real easy to see the common denominators. So this fraction here is like, hey, wait a minute. This one has an x. I want an x. So it gets an x times x. And this fraction over here is like, hey, wait a minute, this one has an x plus 4. I want an x plus 4. So you multiply by x plus 4. Now, the term on the right already has an x and an x plus 4. It already has both toys. So it doesn't need any more. You don't need to multiply this one by anything. It already has both denominators. So in this process of multiplying by common denominators, your denominators will cancel out, including this down here. And we multiply. Let's change colors here. 12 times x is 12x. Now we have to be careful. This is actually a negative 7. So it's negative 7 times x is negative 7x. Negative 7 times 4 is negative 28 equals 22. 12 and negative 7x is 5x minus 28 equals 22. We're going to add the 28 over here. And you get 5x equals, I think, 50, right? And then divide by 5. X equals 10. So sometimes you'll get one answer. Sometimes you might get multiple answers. This can get, so number 9 is very similar to the one we just did. Number 10 would be a problem where you would have to factor this first to see what's missing. I think it factors to x minus, nope, not 5, x minus 4 and x minus 1. So you can see that this fraction would need the x minus 1, and then this one wouldn't need any, and then this one would need the x minus 4. And so you just multiply everything out and solve. That's it. That's solving rational equations. If you need any more help, please don't hesitate to ask. Thanks.